We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system. Now, astronomers have captured that moment live, streaming in real time around the globe of them watching all of this. Take a look at this.
From beyond the heliopause, it slipped into our skies. 3I/ATLAS, our third interstellar visitor.
It's moving at a velocity of about 135,000 miles per hour, so it's going really fast. For that distance from the sun, this is really exceptional. You have to be an interstellar object to be going that fast at that distance from the sun.
Yet this one feels different. Its glow is strange. Its path is unpredictable. We never saw it coming until it was already here.
This is an object, if that is the size of it, that is 1,000,000 times more massive than the previous interstellar objects we've seen, and that's quite unlikely. There is not enough material in interstellar space.
Could it be only a fragment of ice and dust, wandering endlessly? Or something crafted, something ancient, something watching? Whatever its nature, the silence of the stars has been broken again, and we cannot look away.
Right now, it's inside the orbit of Jupiter and is headed for its closest pass to the sun at the end of October. That's going to be barely inside the orbit of Mars, and then it's going to keep going on its way out of the solar system.
3I/ATLAS, the interstellar visitor. Space is full of rocks, but every now and then, one comes along that makes astronomers sit up a little straighter. That's exactly what happened with 3I/ATLAS, an object that has gone through a few different names in the short time we've known about it. At first glance, it looked like just another faint dot in the sky, but where it came from and where it's going makes it a whole lot more interesting. On 1st July, one of NASA's Atlas survey telescopes in Rio Hurtado, Chile, was busy with its nightly job, scanning the skies for moving objects. Atlas, short for Asteroid Terrestrial Impact Last Alert System, uses 4 telescopes spread across Hawaii, Chile, and South Africa. Each night, they snap about 800 images, keeping track of near-Earth objects that drift close to us. But that night, the Chilean telescope spotted something unusual. Unlike many other surveys that avoid the bright galactic plane, ATLAS has the tools to look directly at it without being blinded. Pointed toward the Sagittarius constellation, the telescope captured 4 images of an object racing toward our solar system.
This is a raw image, so this is not even this is just directly from the telescope right now.
The Minor Planet Center in Massachusetts confirmed this wasn't just any rock. When astronomers checked old images, they realized that both ATLAS and the Zwicky Transient Facility in California had unknowingly recorded it weeks earlier. With all that data, scientists mapped its path and discovered something shocking. Its orbit wasn't from around here. It was hyperbolic, meaning it had flown in from interstellar space. That earned it the official title 3I/ATLAS, the third interstellar object ever spotted in our solar system. Astronomers are buzzing with excitement. Michelle Bannister, a researcher from New Zealand, said that studying past interstellar visitors transformed how scientists understood space. This new one could do the same. More telescopes will be tracking it in the months ahead, and each observation might bring fresh clues about what lies beyond our solar system. The big question is, what secrets will 3I/ATLAS reveal before it sails back into the dark? A cosmic trilogy. To understand why astronomers are buzzing about 3I/ATLAS, we need to look back at the short but dramatic history of interstellar visitors.
Just weeks, Atlas had gone from a faint speck to a fully realized comet with a streaming tail.
In 2017, the world met its first Oumuamua. Long and thin like a cigar or perhaps a flat disk, it moved through our solar system in eerie silence. It had no comet-like tail, no obvious features, yet it accelerated as if something unseen was giving it a push. The mystery left scientists scratching their heads. 2 years later came Borisov. This one looked more like a classic comet, with a clear tail streaming behind it. But it was unmistakably alien in origin, carrying chemical fingerprints, unlike anything born in our solar system. Scientists were thrilled. We were witnessing interstellar travelers with our own eyes. Still, questions lingered. Why now? Why suddenly? Fast forward to today, and 3I/ATLAS has turned up the excitement even more. Unlike its predecessors, this object is brighter and possibly far larger. If its surface is as dark as an asteroid, then it could stretch up to 12 miles across, making it a true giant compared to Oumuamua and Borisov. That sheer size alone has sparked fierce debates about what it really is. Telescopes around the world locked onto it as soon as the discovery was announced. Over 100 observations poured into the minor planet center, confirming its origin. Interstellar space. Even more intriguing, its path seems to point back toward the galactic center, a region filled with violent forces and still poorly understood by science.
The good news for science is that now the tale is out, we can study the comet in far richer detail.
Some voices are pushing the conversation further. Avi Loeb, the controversial Harvard astrophysicist, has called for the James Webb Space Telescope to watch 3I/ATLAS closely. He hopes to detect any unusual movements, shifts not explained by gravity alone. If such deviations exist, they could suggest something extraordinary, perhaps even artificial propulsion. Most astronomers remain cautious, sticking with natural explanations like comet activity. But the what-if lingers at the edge of every discussion. Traveling at 152,000 miles per hour. Even though 3I/ATLAS is heading our way, Earth will be at a safe distance. At its closest, the comet will still be about 1.6 astronomical units away. That's over 600 times farther than the Moon is from us.
When the comet is approximately 170 million miles from Earth, and the geometry improves again.
So, there's no need to panic. Instead, we get the rare chance to sit back and watch its incredible journey unfold. What makes this comet so fascinating is its orbit. Scientists measure orbits using something called eccentricity. A value of 0 means a perfect circle, while anything above 1 means the object isn't bound. It can escape gravity and keep moving freely. Well, 3I/ATLAS has an eccentricity of around 6. That's extreme. In fact, it's one of the most hyperbolic orbits ever measured, which explains how it managed to travel such unimaginable distances across space before crossing paths with us. But orbit isn't the only mind-blowing thing here. The speed is just as shocking.
It's moving at a velocity of about 135,000 miles per hour, so it's going really fast.
Right now, 3I/ATLAS is racing toward us at about 36 miles per second. To picture that, imagine sprinting across 580 football fields every single second. That's how fast this comet is moving. For comparison, our earlier interstellar visitors, Oumuamua and Borisov, were zipping along at 16 and 20 miles per second. Atlas easily leaves them in the dust, making it the fastest interstellar comet we've ever seen. Astronomers, of course, want to know exactly where it's heading. Its orbit is heliocentric, which means it's centered on the Sun. By studying this path, scientists have worked out that 3I/ATLAS will swing past Mars in October 2025. Then, on the 13th of October, it will make its closest approach to the Sun, about 1.4 astronomical units away, just inside Mars's orbit. Unlike Oumuamua, which skimmed much closer to the Sun in 2017, Atlas will follow a wider path more like Borisov's. After looping past, it will slingshot right back out into interstellar space, continuing its long journey into the dark. And while its orbit and speed are already extraordinary, the real surprise comes when astronomers take a closer look. An asteroid or comet. When 3I/ATLAS first appeared in our skies, astronomers couldn't decide what they were looking at. Was it an asteroid, a dry, rocky body silently moving through space? Or was it a comet, an icy traveler that, when warmed by the sun, releases gas and dust?
All there is to know about NASA's latest observations of Comet 3I Atlas.
For weeks, the answer wasn't clear. The turning point came when telescopes spotted something faint but unmistakable. A coma, that hazy cloud of dust and gas that forms when ice begins to vaporize. Suddenly, the object didn't look sharp like a star or asteroid. It looked fuzzy. And fuzziness, in astronomy, is a dead giveaway. It meant material was escaping from its core. In fact, astronomers had noticed unusual signs even before the official discovery date. Using powerful observatories like Canada, France, Hawaii, and Las Cumbres, they saw faint activity that hinted at dust and gas leaving the surface. Atlas wasn't behaving like an ordinary asteroid at all. Then came another clue: its path. Unlike asteroids and comets that orbit the Sun in neat closed loops, ATLAS is on a hyperbolic trajectory.
So far, they've discovered that this mysterious visitor is moving at an incredible speed of 61 kilometers per second relative to the Sun.
In simple terms, it swooped into our solar system from interstellar space and will eventually leave again. That alone makes it rare. Combine that with a visible coma and tail, and the comet classification became clear. Still, ATLAS isn't your typical comet. As it got closer to the sun, its activity grew stranger. Its coma expanded rapidly, dust streams thickened, and its tail lengthened, all signs of volatile ices being released. Spectroscopic studies, using instruments on the VLT and JWST, detected gases like carbon dioxide in surprising amounts. The ratio of carbon dioxide to water in its coma was unusually high, far from what scientists normally see in comets. And water isn't the only mystery. Its strange glow has now raised even more questions. Why 3I/ATLAS suddenly glowed green? For weeks, astronomers tracked 3I/ATLAS as it changed from a faint speck into a full-fledged comet. Streams of dust and gas poured out as sunlight heated its icy body.
As insolation ramps up, volatile ices sublimate faster, dragging dust off the surface to form a brighter, broader coma and tail.
But just when scientists thought they understood it, ATLAS threw a curveball, and it began to glow green. The first signs of this glow appeared during September's total lunar eclipse. With the moon's light hidden by Earth's shadow, astrophotographers Michael Jerger and Gerald Raymond captured crisp images of the comet.
Suggests that the interstellar object may be developing a striking green tint.
To their surprise, the photos showed a soft emerald haze surrounding it. This eerie glow hinted that unusual chemistry was unfolding as ATLAS moved closer to the sun. But why green? Other comets, like the dramatic Devil Comet and the newcomer SWAN-25, have displayed the same color. Normally, the cause is dicarbon, a simple molecule made of 2 carbon atoms. When sunlight hits dicarbon, it fluoresces green. Simple enough. But Atlas is different. Earlier studies had shown no trace of dicarbon in its spectrum. So if not dicarbon, what was behind this mysterious glow? One idea is that the molecule had been trapped beneath ATLAS's crust and only now was being released by solar heat. Another theory is that something entirely new, another mix of gases and dust, was producing the emerald glow. Either way, the comet's chemistry was clearly unlike anything seen before. NASA quickly got involved. The James Webb Space Telescope revealed a strange ratio of gases. Carbon dioxide was nearly 8 times stronger than water vapor. For a comet, that's extreme. At the same time, the Hubble Space Telescope placed a surprising limit on its size, around half a mile across. For something so small, it was releasing a huge amount of material, more like a much larger comet. And then came another odd detail. Ground-based telescopes picked up nickel gas in the comet's coma, but found no iron. Normally, both metals appear together. This break from the rules suggested Atlas was born in a very different corner of the galaxy. When comets heat up. Look at 3I/ATLAS through a telescope, and it doesn't appear sharp like a star.
The 3I, marking it as the third interstellar object ever discovered.
Instead, it looks fuzzy, almost smudged. That's because its solid heart, the nucleus, is surrounded by a huge cloud of dust and gas called a coma. This coma forms when the sun heats the comet's icy surface, turning frozen gases straight into vapor. As the gas escapes, it drags dust with it, creating the hazy envelope we see, and eventually stretching out into a long tail. Right now, ATLAS is already impressive, but the real show is only just beginning. The closer it gets to the sun, the hotter it will become.
Even closer to the sun, astronomers were astounded to see Comet Lovejoy's tail glowing in extreme ultraviolet light as it approached the sun.
And as it heats up, the comet's buried ices will begin to sublimate faster, releasing more gas and dust into space. Think of it like a frozen soda can warming up. The pressure builds, and eventually, something has to give. For comets, this can mean sudden outbursts, where the surface cracks and a burst of material explodes outward. To us, it would look like a cosmic firework, a dramatic brightening in the night sky as fresh dust and gas blast into space. Sometimes, this heating can go even further. If the stress is too much, the comet's nucleus can break apart entirely. That's not just a theory. We've seen it before. The last interstellar comet, Borisov, shed fragments during its journey, leaving behind smaller chunks, like shattered glass. Atlas could follow the same path, though so far, as of August 2025, it stayed steady without any major eruptions. But even without breaking up, ATLAS is already enormous in scale. High-powered telescopes have measured its coma stretching nearly twice the size of Earth. And NASA's Sphere X mission spotted something even larger, a massive cloud of carbon dioxide gas surrounding it, extending hundreds of thousands of miles. From Earth, this all looks tiny, since the comet is so far away. But in reality, Its halo spans distances you could never walk in a lifetime. Early images even showed the coma growing rapidly over just a couple of weeks. It swelled by thousands of miles. And as it continues its journey inward, that growth is expected to accelerate, the comet becoming brighter and more active the closer it gets to the sun's heat. So while Atlas may seem calm right now, the story isn't finished. As it heats up, it could burst, flare, or even split apart, turning its long, quiet journey into a sudden interstellar fireworks show. 3I/ATLAS and its mysterious tail. Here's something exciting. 3I/ATLAS has a tail. When first measured, the Minor Planet Center reported it to be about 3 arc-seconds wide in the sky, at an angle of 280 degrees. That might sound big, but in reality, it's short compared to the massive tails we often imagine. In fact, in many telescope images, the tail almost blends in with the surrounding coma, the hazy cloud of gas and dust around the comet's core. But what makes this story even more fun is how modern technology has brought everyone into the game. Thanks to better telescopes and instant communication, both professional and amateur astronomers are following 3I/ATLAS closely. Around the world, people are snapping pictures, analyzing data, and sharing updates in real time. A popular hub for these findings is the Astronomer's Telegram, a forum where enthusiasts post their results. It's updated almost daily, and one of those posts, by Miguel Alarcón and his team, revealed that the tail actually stretches more than 15,500 miles. That's a huge leap from the first estimates. Beyond its tail, scientists are studying what the comet's surface might look like. Here, 3I/ATLAS shows a familiar pattern. Like its interstellar cousins, Oumuamua and Borisov, this comet is redder than the Sun, and even slightly redder than D-type asteroids found in the outer belt of our solar system.
3I/ATLAS, only the third interstellar object ever observed after Oumuamua and Borisov.
The redness comes from the light reflecting off its coma, which can overpower the signal from the solid nucleus inside. This effect was also seen with Borisov, where the glowing coma drowned out much of the nucleus's light. As 3I/ATLAS moves closer, astronomers expect sharper measurements that will help separate the signals and reveal more about what's hiding at its core. We can also make comparisons with past comets. For example, in 2020, Borisov was seen producing dust at an astonishing rate of 110 pounds every second. If 3I/ATLAS behaves the same way, its coma will only grow brighter and larger as it continues its journey toward the sun. Finally, the discovery of 3I/ATLAS has given scientists fresh data to estimate how many interstellar objects might exist. Some objects might simply be too small to detect, or perhaps they emit signals our telescopes can't pick up yet. And that leaves us with the big mystery. How many more interstellar visitors are slipping past unnoticed? Alien spacecraft. On 16 July 2025, astrophysicist Avi Loeb, famous for pushing bold ideas, suggested that maybe, just maybe, this comet-like traveler could be something artificial.
Harvard professor Avi Loeb says aspects of these images, including the brightness around the object and its unusual trajectory, suggests it's not natural.
His reasoning? Atlas doesn't quite behave the way we'd expect from a normal comet. For starters, its size appears unusually large, and its path through space is oddly aligned with the solar system's ecliptic plane. That's the flat path where most planets and asteroids orbit. To some, this looks too neat to be a coincidence. On top of that, early observations showed a lack of familiar comet chemicals, making it even stranger. To Loeb and his team, these anomalous traits left open the possibility that 3I/ATLAS could be an alien craft, or at least carry remnants of one. Of course, science always looks for natural explanations first, and soon after, other observatories began detecting more familiar comet signatures. The Swift Observatory picked up hints of water vapor and OH between 31st July and 1st August. A few weeks earlier, in mid-July, the Very Large Telescope spotted nickel vapor, and by mid-August, it identified cyanide gas. These chemicals are perfectly normal in comets we've seen before, reminding us that ATLAS might just be another icy rock from the depths of space. But Loeb isn't backing down. He's quick to admit that the most likely outcome is that ATLAS is natural, probably just a comet. Still, he argues that asking the question is important. What if some interstellar objects really are alien technology? Even if 99 out of 100 turn out natural, that one exception would change our place in the universe forever.
NASA scientists say it's a comet. It could be alien technology. You heard that right. So, Does this mean ET is real?
What do you think about this theory? Because it's not the first time Loeb has stirred debate. He made similar arguments about the cigar-shaped Oumuamua in 2017, which showed strange acceleration without a visible tail. He's also speculated about interstellar meteors carrying signs of alien engineering. What ATLAS means for observers. If you've been curious about 3I/ATLAS, there's good news. You can track its journey across the sky.
3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system.
Over the past few months, astronomers and sky watchers alike have been keeping a close eye on it, sharing updates and images from different corners of the world. Back in July 2025, the comet started its journey for observers in the constellation Sagittarius. By the second half of the month, it had moved into Ophiuchus and brightened noticeably. From there, it continued across the night sky, gliding through the constellations of Ophiuchus, Scorpius, and Libra during August. By September, it remained in Libra, becoming easier to spot as it drew closer to the Sun and picked up activity. What makes this so exciting is how fast the comet has changed in a short time. In just weeks, its coma, the glowing cloud of gas and dust surrounding its core, grew dramatically, and its tail stretched thousands of miles across space.
This chemical often appears in the coma, the cloud of gas and dust that surrounds a comet's core.
Each night brought a slightly different picture, making it a rewarding target for anyone following its path. As October approaches, the comet is on its way to perihelion, its closest point to the Sun. From Earth's perspective, this means it will move into solar conjunction, lining up behind the Sun for a while. During this period, it won't be visible from our planet, but that doesn't mean the show is over. On its way around the Sun, 3I/ATLAS will pass close to Mars, where orbiters may catch incredible views as it brightens further near the red planet. Once it swings past the Sun, the comet will return to Earth's skies. By November 2025, you'll be able to see it again just before sunrise. It will rise earlier each day, becoming a familiar sight for sky watchers as it moves away from the Sun. In December, 3I/ATLAS will travel through the constellations Virgo and Leo, still offering plenty of chances to observe as it continues its outbound journey. Watching 3I/ATLAS isn't just about one night. It's about following an interstellar traveler on a months-long trip across the heavens. Each new position in the sky, each change in its tail and coma, gives us a front-row seat to something truly rare. After all, interstellar comets don't swing by every year. This is a moment to enjoy, whether you're capturing images through a telescope or simply tracking its progress through shared observations online. We hope you enjoyed this video. Stay tuned for more amazing stories.